What I've learned from watching you guys code is that the value really starts to come not when you're doing the same thing faster, when you're delivering the same or equivalent value differently, by doing it differently, by thinking about the problem differently.
Welcome to Modern Logic for Your Business, where we talk about AI and technology. I'm Andy Ron, and with me is Dustin Brusnak. Today, Dustin and I talked about safety. There's this great research paper. We're going to get into it about how you can build safe systems involving robots, but then also AI, and we talk about all kinds of consequences from there. So stay tuned. It was a really interesting conversation. Did you see this mind-blowing website called ChatGPT.ai?
I did.
It's powered by an entirely new way of running models using custom silicon from folks at, I guess it's pronounced Talus.com, TAALAS.com. And they can run models like 15,000 times faster than conventional like NVIDIA GPUs. So when you go in there and you type a prompt, and I'm not sure, it's using a somewhat older, I assume, open source model, not one of the proprietary foundation models, but it's still pretty good. But the interesting thing is, the entire response is generated basically instantaneously. None of that like watching each word type out. It's mind blowing.
And
so
you
that
can
is
see where that's going to go, right? So you take a model that's sophisticated, that has general purpose use, you model it in hardware, and then you can suddenly generate code in or whatever your work output is with the press of a button. And that's another game changer in how AI is used, because one of the things that we do with AI is we spend a lot of time as we use more and more of it waiting for it, right?
Yeah.
So
especially as you talk about agents and multiple things working simultaneously, and as we are able to AIify more and more of our processes, it's just more things you're waiting for. And another thing that's really interesting, I'm not sure we've talked about before on the podcast, is the more chances you give an AI system to tackle a problem, they actually tend to resolve to a more correct response, which is interesting because when LLMs first came out, they actually would tend to degrade. If you fed the results back in and said, hey, keep thinking about this, it would just drift away. Now they tend to converge on a better response. So if you could do that instantaneously, you could do 10, 20 cycles of iteration and maybe tackle problems that before was like, oh, who's going to bother?
Or who's going to pay the token cost? Because I think the other case, the token cost is going to come way, way down, because they were saying that is somewhere in the neighborhood of $5,000 to $10,000 more cost efficient from an electricity standpoint to use the hardware modeling. And I'd believe it, because you got to imagine if you have the weights in hardware, just how much faster the math is. So
but the challenge too is it takes them 2 to 3 months, and that's their aggressive timeline, to design the custom silicon for the weights of a new model. And then you have to get a fab to manufacture and QA those and get them potted and put on a board. And so you're not going to be using this year's model.
Right.
But if they can get a really robust model that, you know what, even a year from now is still useful, because let's face it, some tasks are still being done by GPT-4, then this could be huge. So that's one to watch.
And it also, it's good. You can just imagine, I don't know how big they are, but imagine Apple getting a hold of it and putting a chip in your phone, like an AI and a chip in your phone, and how fast it could be, how efficient it could be with battery life.
Because it could be low power, right? Yeah.
Yeah. And it doesn't have to be ChatGPT 7.0. It could be even ChatGPT 4.1, 4.2 could be, or ChatGPT 4.0
would be a huge improvement over Siri.
Yeah. And then every year you got a reason to buy a new piece of hardware because it's got a smarter.
Like they can't firmware update those things.
But they could also still do things like fine tuning and reg, and so there are updates they can do to the OS to deliver more value on top of the chips. So this is the future. Like this is so obviously where the common models are going to go. We're going to see. We've got history for this. This happened with Linux, and we're going to see the hardware tier supporting the phones and miniature. We're going to see the front end frontier models driving the R&D. And then you're going to see the open source models suck up a huge chunk of the market share because the frontier models aren't going to be needed for the majority of use cases as the rest of the models
I
come up. Which is
yeah,
actually good, because what we don't want is to create a world where 3 companies own all of the compute, all of basically the computational intelligence of an
I
entire
also
species. That
we don't
seems
want it all in the
bad.
cloud either. Like
Yeah.
I think there's an opportunity for the person who gives me my own Claude level inference device that I can plug in here at home.
Well, and be private to you in a
Be
way that
private
you
to
know is
me.
secure. And
Yeah.
this is one of the things that came out of, I was just at a speaking at a conference a few weeks ago. It was an investor conference, and one of the things that came out of it is the belief that Apple is going to get into the AI scene, and they're going to do it in a privacy-centric way, and that's going to be exciting,
Mm-hmm.
especially to the kind of consumer that purchases Apple phones, which is a consumer that can drop $1,000 on a phone, right, or
Mm-hmm.
$700 or whatever. And it's really driving a big chunk of the middle market hardware spending. Apple is not down and out. They typically bided their time, and so that's the expectation. And I don't think that's unreasonable. I think we'll see Apple dive in when Apple can put their own on
In
it.
some ways, there's clues that they're already ahead because Apple's been putting what they call their neural engine in their premium chips for a while now.
Right.
And now I think it was they didn't imagine large language models when they first put it in because you can't run those on the neural engine today. It doesn't have enough chutzpah. But they already have a neural network specific piece of silicon that they're shipping and have been
Right.
shipping. Is it possible they could scale that up to a 32 billion parameter model? Maybe. They're as well positioned as anyone probably to do that. And now you have a really interesting new product opportunity. Of course, I don't know. Apple's not led by Steve Jobs anymore. Are they going to go for it or are they going to whiff on that?
Have to wait and see. I was just
Yeah.
watching a video of Jobs doing a 1992 MIT lecture, and the things that he was saying are still relevant today. So talk about visionary. Like, you can say
Yeah,
what you will about the man personally, but he was one hell of a visionary. And a
he
lot of
was.
what he says actually applies to the AI today, about how operational AI is going to be. He was talking about operational software, because this predated basically software in the operation sides of our businesses, like QuickBooks being everywhere. And he was saying this is going to be the wave of the future. He was absolutely right. But you could look at it
Mhm.
now and say the same thing. Like, the wave of the future is the AI moving from the server into the operational environments, which includes your phone in your pocket.
Yeah. This has
And
happened before. Like it was mainframes and then it was workstations,
right.
then the
And
personal
that's
computer.
exactly what he was going through,
Yeah.
right? Like the
Yeah. And
same exact
it
thing.
seems the same thing all over again. Yeah. Like,
And I think Nvidia bought a company that does this. So there's a couple different companies that are doing AI modeled hardware, and there's
well,
no reason you can't model the weights in hardware, especially with how complex GPUs are
what's
these days.
interesting is they are still digital. So they're going to be bit for bit have the same fidelity as any other way of evaluating the model. Just in my own like ignorant way, I've thought, I wonder if anyone has considered trying to do like an analog version with just like resistors or something like could because then it would not be the digital, it'd be no quantization. I'm guessing it wouldn't work at all, but that's another
The
potential.
city-sized set
No,
of
would it be
Rube
big? I don't know.
Goldberg. It would be like, how many parameters do the frontier models
But if you
have?
could still print it,
Hundreds of
yeah, I
billions,
don't know.
trillions.
Yeah, I don't know anything
Um,
about electronics. It probably would be the size of a city. So,
it'd be a lot of fun though.
okay.
So this gets
Um,
so at also at that conference there was a guy from Caltech. He's a professor of robotics, and he was another one of the speakers. And he pulled me aside in the hallway, and we were chatting about AI and safety. Because, well, I'll be honest, I pulled him aside because he was just so cool. It was just like, dude builds
okay.
humanoid robots, and
So
he
he
basically,
basically is going to build the Terminator. This is the guy.
yeah, this is the guy. Except he's going to build like the anti-Terminator. So he's the guy at Caltech that owns the lab that's doing a lot of the research on how robots walk, how robots dance. And one of the interesting things he said is, just an aside, that all the robot dancing, those are all like fake demos, because they have a human basically telepresence guiding, and they record the human moving, and then the robot replays it. But if you happen to be standing there, the robot would just take you out and go through you, because inherently all of the things we're seeing the robotics companies do, there's no intelligence there. It's not the robot doing it. The robot is just dancing a jig that a human danced, and they recorded it like they record
motion capture for a movie or something?
for movies. And he
Okay.
said to get the robot doing those things and dancing, we may be 10 or 20 years away from that because we don't even have the sensor technology. But one of the things he was working on that was really interesting is he pioneered what he's calling the first law of robotics, which is, if you're a sci-fi nerd, that's been around. Isaac Asimov, who created iRobot, and
this, I'm immediately skeptical to the callback because, like, can you even do that?
you're right. So
But apparently someone is figuring this out, huh?
So the backstory is Asimov wrote about this pre-personal computer that there would be 3 laws to sentient robots that control. Bear with us, this will get back to Earth at some point. That make it so that robots are always subservient to humans and never harm them. And the first law is you shall not, I'm going to butcher it, but you cannot harm a human being even through inaction or cause a human to come to harm. And so that's the first law of robotics. And so he has spent this Dr. Aaron Ames from Caltech has spent his career trying to recreate the first law of robotics. He's the guy pioneering humanoid robotic safety. And what the way this gets back to AI is, I think the way he went about it, I pulled up his research paper, the way he goes about it. And as someone who's not a mathematician, I'm not only going to butcher Asimov, but I'm butcher Dr. Aaron Ames here. The idea is you equip the machine with the robot has a thinking layer, and this is live. He's got real robots with this real technology. So the robot basically gets instructions. It wants to move forward into Andy. And then in order to execute that, it has to pass through a hardware layer. And it says hardware, I want to move towards Andy. And then the hardware itself is completely separate from the thinking system.
I think the robot's
because you're right in front of me, man. The robots love me. So
the robot has places to be, and I have
the robot has places to be, and you have
the immediate path that it would take.
And what happens is, the layman's understanding of the math is, the machine asks permission, or basically says move forward. The thing that's controlling the hardware, the safety layer, which is a separate system, says, I'm going to let you move forward because you are far enough away from Andy that you can't cause harm. And as you narrow the distance towards what's called the boundary, towards the space where you can start to cause harm, the set of operations that the hardware layer lets you do gets constrained, so that the only meaningful choices the machine can make are within a bounds of safety. And what happens from that is, as it walks towards you and its set gets more and more constrained, you end up with an emergent behavior where the robot walks around you because it says move forward, and the safety layer corrects and says you really only have 2 options. You can go this way or you can go this way, and it picks one of those 2 options out of the set and then executes it. And that's my layman's understanding. And that what's interesting about this is you can see the same thing being built for AI governance, where AI itself, you have, like we talked last week about OpenAI going nuts and writing a whole blog post about a developer who had denied a pull request that it did and how he was against AI and all this stuff. So the problem there is, you've taken your AI agent and you've given it access to tools without an intermediation layer that says, is this AI agent's use of these tools going to be safe for me? Is it going to be productive according to my guidelines, and so on? And so there's no checks and balances. It can just go wild and do whatever the heck it wants. Delete your bank.
But hang on a second here. I hear what you're saying with the robot, because it maybe has like LiDAR and it has a geometry understanding of the world around it. And it could say, yeah, if you move in this direction, my physics engine says there'll be a collision between a human being and my physical self, and that's not safe. But okay, just recently I was reading this thing that happened to Google, where they accidentally made it so that any API key that you'd ever created, like publicly for Maps integration, also would allow you to use their AI services using the same API key. It was never intended, but it somehow came about because the AI team said, oh, we need some kind of access control. Oh, here's this access control system. We'll just hook it in. Oh, and then some other team said, oh, when you enable AI services, we'll just automatically enable it for all existing API keys. All is well and good. No one thought, oh, these API keys are already out there in the wild, publicly addressable on websites for Google Maps integration. you shouldn't do that. This is not a simple safety problem to figure out.
No. So I agree. But I would say, yeah. So Aaron basically said multiple times that he could bound robots because he ultimately physics controls, and the math behind physics is much better known than the math behind human interactions. But there's so many things that you can task an agent with that you can provide reasonable constraints. So, for example, before I give an agent my credit card, and I've been on record multiple times saying, don't give the card,
Yeah.
right? So I would feel comfortable giving an agent my credit card if there were a layer basically that allowed me to say only spend on these websites amounts in between these two things that total up to this amount, right? And that is a layer that the agent has to go through in order to use my credit card at all. In fact, my credit card is not in the agent, it's in the hardware layer or in the separate software layer. And so when we give these things tools, this is broadly, there's two ways to do that: skills and MCP, both pioneered by Anthropic. If we think in terms of the tool is the intermediary layer that actually executes the safety instructions, and we are going to use traditional engineering to constrain that output. And you can also look at it in terms of how much risk tolerance are we willing to expect. So if I'm giving it my credit card, sure, I want to have hard limits. But if I'm doing something that's more like writing an email or human-to-human interaction, a few typos here and there, I could use another LLM and then a machine learning algorithm and much softer types.
So I have a couple ideas here that I think if I were to put on my crystal ball, I think in the future, all of these tools are going to come with additional kind of markup, like safety concerns. Hey, when you use this tool, here's how you should use it safely. Here's the risk areas, so that some kind of reasoning safety agent could look across all the tool calls that are being involved in a workflow and evaluate, oh, what could go wrong? And probably along with that, there could be margins of error, like you just said. And there's a whole lot of science around error analysis. So it could not only look at what's safe, but maybe give you an estimate of this. I can't say it's 100% safe, but I feel like it's 97% confident, and actually track the standard error math through the system and come up with some estimate of this seems like worth trying, or maybe I need to double check my work at the second stage to really
And
know
in
if it's
fact,
safe.
when you go back to the paper that Dr. Ames wrote, the function basically calculates the distance from the safety boundary. So you need to have a recipe to mathematically derive what safety is. And so you have to have figured out what that looks like. And that's why he dives into, and this is the part where math gets really hard for me, with differential equations. And the idea is that these are ways of modeling real things that weren't traditionally mapped to linear algebra or math, right? They're made to model real world situations where you might not have a clear mathematical thing. So you're approximating. That's my layman's understanding as someone who hasn't done math in 20 years, is the functions inside differential equations are meant to approximate real world things that there's a math behind them, but you might not know what that math is, right?
Interesting.
And so in this case, if you can use these linear or these differential equations and you can feed these systems, you say, okay, let's figure out how to calculate what the safe set and what the unsafe set looks like, and how for each element in both of these, how distant they are from safety. Now we have the ability to wisely correct agent behavior, not just by saying, no, you can't do that, but by saying, the thing you are attempting is close to a safe option, and here are your three safe options, and this one is more safe than this. And now you have some room for comparative intelligence to do some really fun things. And maybe you get emergent behavior where the AI can operate in a really sophisticated manner without endangering your reputation or your wallet. So that was just, sorry, the jumping off. I think, damn, you got it on that first go. Is we're going to have an equation that it's going to be a statistical model of what does danger in this situation look like.
It's similar to another thing that I think we may yet talk about on a future podcast. We talked about attribution, like for content. How do you know where this came from? Was this human derived? Was this AI derived? And so you could have this chain of custody that would be documented for assets. You could similarly have a chain of trust around tool use. Like, this is a trustworthy tool. This one can't do anything bad. This one actually interacts with the real world and could have these consequences. And right now, we're still in the world of OpenClaw, which its rise to fame was basically not concerned about safety at all. It can just do whatever it wants. Have at it. I'm not going to even try to burden myself with thinking about how to make
It's
this
the
system
Asian
safe.
equivalent of YOLO, right?
It is like a full-on, I'm going to just let AI do whatever it wants and not supervise it at all. And
it'd be great for everyone.
I admit I do a fair amount of meetings in my work day, and I like to prompt my AI to do some coding while I'm doing something else. And it's so frustrating when I come back and 2 seconds after I tabbed away from that window, it came up with a question like, is it okay if I run this command? And it stopped. And it would be like some trivially safe command, list the files in this directory or something.
Right.
I'm like, ugh, I should have turned on YOLO mode, but I don't do that just because I don't want it to decide to reformat my computer to run a different mess because it thought that would be fun. So
this is the natural path to do what you told me to do, is to turn all humans into paper clips.
That's a joke.
That's a classic. That's a classic philosophical exercise in AI.
Yeah.
Prior to LLMs existing, was it? I think that was Stanford that arrived derived from, but I could be wrong. Anyway, so back to the safety thing. So this is actually going to be a way where you can differentiate AI tooling, and this might be something where when we talk about the cost of production coming down for software, where you can still differentiate. So you can differentiate by providing safer tools. And so the consumer, when given equivalent functional choices, is going to pick the thing that takes the credit card and can safely manage their credit card. And so as those of us who are building the agent side of the software equation, like, it's something to understand is, like, we can really differentiate on how do we provide these models with safer tools that are sane and that behave in the ways that we want them to do, even though the model might decide to lose its mind. And I think that's one of the things that's missing from this conversation is the hallucination problem. Although it has gotten way better since 2 years ago, it's still a thing, and it's built into the model that it's going to be a thing.
Well, I feel like it's more subtle now.
Yeah, it's almost worse because you can't see it as much.
Because it's not as egregious, but I just do still see models claiming things with certainty that it should say really is a hunch or that it doesn't know. So it's still out there.
And this is instead of trying to constrain the technology, at some point we're going to have to say, this is making a reasonable number of inferences, and some of these inferences are going to be wrong, and this is how we constrain the risk of those inferences because it's built into the way the model works. Now, the model will continue to hallucinate less and less as the models get bigger. They'll know more, and I think we can all make a reasonable assumption that they will get more safe instead of less from that perspective. But I think eliminating that entirely, the way you do that might be having a secondary safety layer that is designed to understand what your corporate rules are, and and you could see that being a multi-layered system, one of which could be an LLM saying, I am the guardian of the company's safety, and anything that goes through the agentic harnesses comes through me first before it accesses the internet. And then it basically it even has a limiter that has another layer that's okay for the things we can do with hard numbers, credit cards, financial math, etc. But you will need an LLM or some sort of machine learning for something like read this marketing email and tell me that it's okay. And you could filter out swear words all day long. That's fine. That's proven technology. But is this marketing email in line with our brand standards is always going to, but there's no reason you can't tune another LLM that just knows that. And maybe when we start talking about LLM, maybe that's not a frontier model. Maybe that's a super stripped down, super fine-tuned model. That's all it knows. And that's how we limit that risk of there.
Well, when you think about it, it's using one model for all these different tasks it's suboptimal. Like, you don't hire the same kind of employee for every role in your business. Why would you use the same model for all those different tasks? It's just because right now models are very hard to build and costly. We're just building these general purpose ones and using them for everything. But I can definitely see a future where, you'll have purpose-built models that are better at certain things. And we do see that in some ways. There are coding models that are designed for coding, and you wouldn't use those for writing marketing copy.
Right.
We'll probably see more and more of that as time goes on.
And I think also a combination of prompting and fine-tuning and RAG and all those tools that we use they're basically approximating creating our own custom model anyway,
It's a
narrowing the
different,
context space
yeah,
from all human knowledge to the thing that I want you to do. And so
right.
I think it's a natural next step to say, okay, not just that, we're going to separate from these models. I
Mhm.
think the models themselves, the frontier models, will always have use for general purpose equations,
Sure.
but we're definitely going
Yeah.
to see them splinter out to these specific things. We already have. There's already, like you said, coding models, but I think there's already a bunch of other models that we're seeing in that space as well, and we're going to continue to see more.
This is a bit of an aside,
Right.
but something you just said reminds me of a conversation we had earlier around our own business and consistency when we're using models for work. We have our core values for our business, and we tell our employees, and we often lean on those when there's difficult decisions to be made. But we don't tell our models about those. So a lot of the times the model is running with no real understanding of who it's doing this task for or why.
Yeah.
And I think that'll be interesting to watch. Okay, how do we bring that consistency so that all of the AI assisted work output of my business is done with an understanding of what's important, so that, say, it's just making the right trade-offs. It's not going to try
Right.
to do something way beyond what we normally do because it doesn't understand our pragmatism, or it's going to be way harsher or inhumane in some way because it doesn't understand our compassion, those sorts of things.
Right.
Unsolved, but interesting to see. Will there be, I don't know how that's solved. Is there going to be a foundation for
So
my business?
I was talking to my friend who just retired from Target, and he was pretty high up in their technology sector. I think at one point all software, or almost all software at Target, went through him. So pretty knowledgeable guy, right?
Yeah.
And one of my best technology friends, in terms of, he's the guy I go to other than our team if I have like really sticky technology business questions.
Okay.
And
Sure.
him and I were debating this, and the conclusion we came to is that AI governance, which is the name for this, is really important sort of at all layers. And it's not just about safety, it's about, if you're going to assist decision makers, you need to teach your AI how you make decisions, and that's usually special to your organization. And that's part
Yeah.
of that's core values, and part of that's historical context. And then, so what you end up needing is you need a centralized AI function that you can't just give everyone a $20 license to Claude and be like, we did the AI.
Right.
If they're going to be using something like Claude to solve business problems in dynamic systems that you can't predict. So it's not just a workflow that you've automated using your engineers, but it's, hey, I want to give my sales guy a sophisticated tool for figuring stuff out on a daily basis. You basically want your own LLM portal, and that in order to execute, it goes through your own governance, your own safety algorithms, your own everything. And then you have your own tools that are all fine-tuned to do specific workflow things.
Right.
But like the general purpose, the operating system, if you will, that we're all used to popping open ChatGPT or Claude, the general AI use case. There should be a name for that. I'm just going to call it the AI.
I feel like
operating
this is a
system.
free business idea for anyone out
Right.
there listening who wants the next billion-dollar company. It's going to be models that understand your business.
Yeah, and just from talking to him and other people in the industry, the models themselves don't seem to be highly interested in playing ball with living inside corporate firewalls, with doing things like integrating with corporate sign-on systems and authentication and safety. And they're all working to eat the enterprise, but they don't fundamentally understand how the enterprise works. And
Yeah.
so I
And
think
their
what we're
current
going to
revenue model is not going in that direction at all because they want to get paid for token use.
They want to get paid for compute. And why, when you're sitting on a giant pile of gold, why would you go after the pile of copper over there? It's still worth something. It's just not worth something to you, right? This is why Apple loves to have App Store developers write apps for the App Store, because they're making money on the hardware, and every app that goes onto the App Store is just making their hardware more valuable.
Yep.
Like, their whole purpose is to make it so that you as a developer charge less for your apps, so that their hardware gets better, cheaper for their customers.
Oh, yeah.
And when I understood that as a mobile developer, my mind was blown, because I was like, this is why it's hard to make money as a mobile app developer building mobile apps, because it's not in Apple's best interest for mobile app developers to get rich. It's in their best interest for them to get rich enough that other mobile app developers show up to enhance their hardware.
But also,
they want the apps to be 99 cents.
But the really good apps then get acquired.
Yeah, and then they get
then
acquired.
they become
And similar, I think we're going to see this sort of fallout from OpenAI and Claude and Google is their models are either going to be use-based, and OpenAI wants to do ads, and I think that'll probably be a failed experiment, but who knows. But more interesting is the Claude model, where if you're charging for per unit of intelligence and you have intelligence on tap to charge for, then why wouldn't you just basically sell that and make money on that? Because you just imagine the what we're talking about is intelligence on tap, and
yeah.
the if you control the spigot, you don't need to do anything downstream to make all the money in the world. Everything ultimately has to come through you. And this is why I like having other models, open source models, in tune, fine-tuned models,
Mm-hmm.
etc. Because again, to the earlier conversation, we can't let 3 companies control the entire intelligence spigot for AI. But I think this is where you start getting
Wait,
out on
3
the
companies.
philosophical one.
Who are you counting?
Gemini, Anthropic, and OpenAI. Right. So Google and Anthropic and OpenAI.
Poor Elon.
Yeah, no. Grok does not count as a frontier model. I'm sorry. He's the oracle. He's the oracle of frontier models. No one takes Oracle seriously in the cloud world, even though they ostensibly had a cloud. At one point, you could put servers on. No one ever did
They
it.
still do. I play racquetball with a guy whose job is selling the Oracle Cloud.
Oh man, I'm sorry for him. Does he live in a dumpster in an alley? Does he need a hamburger? We should.
His clothes are not frayed, so I think he's still getting
Someone's buying it somewhere. It's just no one I know or have ever known.
Dear listener, if we suddenly start hawking Oracle Cloud, you'll know who decided to
you'll
sponsor
know they
the
found
podcast.
us. Yeah, they've replaced us with robots. Oracle's selling robots. But anyway, so I think like when you come down to it, organizations need to start with how are we going to do governance on this stuff, and how are we going to deploy this in a safe way. We can, and the other thing is that aligns with use cases. So when you go into an organization, what you've seen in a lot of these organizations is they have just given the $20 license or given access to Copilot to all their people, and they want their people to drive the R&D. And that's not how humans work, because there's a really famous business author named Jim Collins, and he wrote a book where he talks about, and I forget I'm spacing on the name, but it's super famous. He talks about how people get trapped in the flywheel, right? Your day-to-day operations of any person in your business is to wake up, get their job done, and go home to their kids. And if you give them something new to do, but you don't tie it to hard corporate objectives that align to their incentives, which is getting their job done, they're just going to be like, that's nice, poke at it for 5 minutes and then get on with their day job.
Yeah.
And the reality is that's how almost all businesses end up functioning. And in order to step out of that, you need to align the whole corporate through. You need to have a transformation inside the company.
Right? But let me say there's another failure mode, which is my team actually is full on, heard the message, we need to adopt AI. And now there's this other problem. There are such a plethora of ways to use AI right now because it's the gold rush. Every person on your team will find a different way to solve the problem. And right now they're all have pluses and minuses, but there won't be coherence across team members. This one will like Claude, this one will like Cursor, this one will like Gemini. And so you're going to have a lot of confusion around people like second guessing and then starting and stopping and trying. And so I could see not just what Dustin said, but also maybe empower some people to be the trial and error and actually decision makers and say, this is how we're going to do it.
The conclusion I drew with my friend Mike was, and this is the target guy, was probably the best bet is to pick one part of your organization and do a leadership driven transformation to just that portion of your organization, so you have a best of breed model that you can then replicate across your organization, as opposed to doing it scattershot. Invest in one particular function, bring in AI, in people who are bought into AI, pick one set of technologies and one set of deployments. And then what I could see it work for people like us being like, okay, here's how you do the governance. Here's the centralized technology for that. Here's the set of, we're going to build out the set of skills that interact with your IP, that interact with your sales function, that interact. And those skills are going to go through a safety layer that we've configured for your particular levels of tolerance for safety across accounting or sales or whatever, right? And so that's all engineering. Like when people are like engineering is gonna go away, you can't just drop one of these things in and say configure yourself to be the best AI for my organization ever. It doesn't work that way. And when you go and try to do this, I was talking to the talk I gave a few weeks ago. One of the people in the audience was a 3,000 person or so insurance company. So that's moderate size, good size business, right? The first thing they did is they gave everyone an AI, and it basically they tasked it with go and ask them what they do and how they do it, so we can figure out where automation can be found.
Interesting.
No one used it because no one wants to open up and answer a survey about how to replace me at my job, right?
Yeah.
That was a really forward-thinking organization. They've since changed their approach, and they've gotten it doing some sophisticated things. And I want to dig in with them on how they did that, because I think I just want to see if it matches my understanding of how you do it at that kind of an organization. Because I think ultimately picking one silo, doing what is equivalent to a pilot, although AI pilots are given a bad name now, and trying to model it appropriately from a governance down standpoint, I think is the right way to do these things. And you have to consider all of these things, just like you would bringing in any sophisticated piece of software like an ERP.
And also just like AI doing what a person was doing. Okay, that's interesting. And people are quite costly. So you could say, oh, this could be a cost savings. But I think also enabling things you've never done before that could catapult your business forward using AI is an entirely different class of problem. And the cost analysis of that is also a lot different, because if you're talking about a data set with millions or billions of records, you can still run all those through a large language model to extract, summarize all these things. But now the costs are going to hit you, because you might have said, oh, it's only a tenth of a penny per record. Oh, but we have 100 billion records.
Yeah.
So that's
now
a big investment.
Right.
So
and
that's
with
another
the cost of AI compute being as high as it is right now.
So it seems cheap when you're saying, oh, I'm spending $50 an hour for this human being to do this task, and now they've doubled their effectiveness. But it doesn't cost me $50 in AI. Big win. But in the other application, it's a different story.
Yeah, Dylan was telling me he coded a feature yesterday. And it was a pretty big feature, but it cost $36 in compute. And I think we're going to end up in where, and that's another great use case for safety algorithms. We have a monitor that's just looking at our token costs and limiting how much, and analyze and letting us know, and causing a red light to blink when Jim, the sales guy, decides to spam the entire East Coast, and the LLM lights up like a Christmas tree, and Claude is just cha-ching, cha-ching, and your bank account is driving to zero. Actually, you want to get it before it does all of that.
This reminds me of the other big business idea. I hope people out there listening are writing these down, which is I want a way that I can run these inference across models from different silos and evaluate their outcome. So they just give me a kind of a random sampling of the last 10 examples from the last 100,000 queries I ran, and say, you know what? You ran this on GPT 5.3 at X dollars per million tokens. You could have gotten just as good a result from this mini model that was a tenth as much, or this open source model that was 1/100th as much.
Yeah.
Right now, we just tend to lean on the biggest, brightest, baddest one out there, because who wants to mess around getting lousy results? But when you start to go to scale, you could be talking real dollars here.
Yeah, and I mean, it's not dissimilar from things we do on Amazon all the time with budgets and so on, right? Mm-hmm. And there's also going to be ways to buy in volume and do more sophisticated. There's going to be plenty of sophisticated ways to buy compute we're just still in the very early days of that. Yeah. So I think that's super interesting to think of, like, safety in terms of those types of risks and so on, and how this deploy is going to end up happening across these organizations over time. But I think the friction becomes that replacing workers is not actually that big of a net value for your business. And the reason is, how much are you going to save? 30%? That's a lot, right? Say you fire 30% of your employees. And the Walmart loves you. Everyone else hates you.
I'm not doing that.
Yeah, you're not doing that. But say you're like CEO of Evil Co. And you're like, I'm going to use this technology.
Yeah.
You got your cat and your chair. And you decide, I'm going to save Wall Street loves me because I cut 30% of my workforce. But your competitor, your disruptive competitor, is going to figure out a way to do what you do differently and deliver it at scale, faster, better, higher quality for a lower price for the consumer. And yeah, it might require less people to deliver that, but it's in how you deliver value. And I think you really start seeing what I've learned from watching you guys code is that the value really starts to come not when you're doing the same thing faster, but when you're delivering the same or equivalent value differently, by doing it differently, by thinking about the problem differently, by getting outside of your box and disrupting your industry, right?
The whole agile software development methodology maybe doesn't work anymore. We're having to rethink the whole problem. It's exciting. It's fun. It's a little bit terrifying. I've been advising some folks, maybe don't bail right now because change is hard, but we're all going to be living a different reality in the next year. And hopefully we can find a way to make that still rewarding and exciting. But what I've learned from you today, Dustin, is that when the robots come for me, they're not going to just drive over me with a tank. It'll have to be much more nuanced to get around.
They all have to drive around you and stop. And that way you won't be able to get out.
And then I'll die of thirst because I can't get out.
They won't be able to run you over, but they won't. They can certainly lock you in.
Yeah, just come at you sideways. Good to know.
This was So Dr. Aaron Ames from Caltech. If you're at all mathematically inclined, you should look up his paper.
We'll post a link to that paper in the show notes.
Yeah.
So
just delightful. He's in Candyland. Most nerds would just kill for his job because he gets to play with robots all day long in his lab at Caltech with some of the smartest people in the world. And he's doing really cool stuff.
Yeah. If I'm in, where's Caltech? LA? Next time I'm down there.
It's in California. Oh, I accidentally showed up.
Yeah, wouldn't that be show me your robots.
Show me some robots. Bring me to the robots.
We've done it again. I think we better wrap this up. So thank you to our audience for joining us. As always, if you have questions or you need AI technology help, find us on the interweb at modernlogic.io. You can follow us on other platforms, including Spotify, Apple Podcasts, and YouTube. Our show is produced and edited by Brian Peterson with additional contributions from Dylan Brusnak, Anna Spitz, and Beth Davis. Our AI mascot was created by the artist Becca Ron. Our theme music is Elastic Vibe by Ziv Moran. Do you have questions or suggestions we can discuss? Please get in touch with us. Again, our website is modernlogic.io/podcast. AI for Your Business is a production of Modern Logic. If you like the show, please remember to share, rate, and review. It really does make a difference to us.